want to welcome on stage the city of Vienna with Michael Meyer. He is an IoT expert and business analyst in the Innovation Lab at Wien Digital. The challenge the city of Vienna is proposing is smart asset tracking for commercial waste containers, which also, by the way, received the most applications and the most teams for this challenge itself. So a huge round of applause to you. Here's your 2 minutes, and here's your applause. Thank you.
Hi, everyone. I'm going to try and speed it up a little bit. My name is Michael. I'm responsible for IoT at the central IT department in Vienna. And I'm going to give you a quick overview of the challenge of smart asset tracking for waste containers. What's the business case about? The waste department of the city has around 1,000 containers, and these containers can be rented by residents, can be rented by companies. So all these containers are distributed all over town. There are around 40,000 transportations a year, and these containers are also quite expensive, as we can see. So the waste department faces a few challenges. The first challenge is the address is not always the accurate position of the container. Sounds maybe a bit funny, but if a driver comes to a certain address, sometimes it's a big industrial area, so it's not that easy to immediately find these containers. The second thing is if you are like administrating these containers in a very basic application, you have a lack of context, so it's somehow also difficult to optimize logistics, for example, when it comes to planning routes. And the third thing is, maybe it's also a bit funny, these containers are quite big and orange, but sometimes they also get stolen or get missing. What we did when we heard about these issues was our approach was to install asset trackers, and these asset trackers are now running for 8 months, so we have a lot of data, and we wanted to use this data as a base for this challenge, what we did, and I think we have 4 presentations to go, so thank you very much, and let's see the solutions. I'm curious. Thank you.
Thank you very much, Michael, and I want to speed it up a little, so please, all our participants, keep in mind we have 4 minutes per team. I want to first announce on stage Mr. Miroslav Mako. He is the CEO of Heliotics. Is he here? Oh, thank you very much. Then we go on, so a little bit time saved for you guys. You're welcome. So, next up on stage is Team Laila Gruber, Magdalena, Schreivogl, Dominik, Steurer, Hubert, Eßletzbichler, Bernhard, Radakovits, and Ralf Hörhager from the University of Applied Science in St. Pölten. Please come on stage.
Ready? Of course. Okay.
Yeah, good afternoon, everyone. We're from the UAS St. Pölten, Masterclass Industry 4.0. And we briefly want to present you our ideas and solutions, as well as a prototype for the Smart Asset Tracking Challenge. To start with, it's important to mention that the city of Vienna already had a basic visualization for tracking the containers, but it was a very rudimental map with little practical usage of the available IoT data. You can see it on the left side. And our goal was to enhance the existing solution rather than build a completely new one. So we wanted to keep the user-friendly dashboard, but add features like geofencing. Geofencing allows to monitor if a container is within a defined area. And we also wanted to improve the back transport of the containers and include theft protection via geofencing. A future idea was also vandalism detection. And yeah, let's move on to our solution. But first, on the right side, you can see the GPS-based IoT device which makes all this possible. The tracker enables functions such as location tracking, geofence alerts, and provides potential for vandalism detection through movement or speed data. So back to the features we implemented. First, geofencing. Alerts get triggered if the container leaves the defined area, in our case a radius of 100 meters, or the city limits, or the MA48 base area. We also added historical location tracking. This allows us to choose a container, and you can see where it has been over a specific time period. Then we implemented route planning, so the user can click on a container and a route gets generated for pickup or return transport. And in addition to that, we also had some future visions like fleet optimization and order management, but this is not yet fully implemented in the prototype, and now I will hand over to Bernhard.
Thank you, Laila. As you might mentioned earlier, our goal was to integrate some features in the basic solution, and therefore a few of you might be familiar with the dashboard. You can see different markers around Vienna representing different colors, which is basically the status of the battery of these trackers, or can also be used as the quality of service or the IoT status. We can select any marker around the map, click on it, and already can see the geofence selected. We get some basic information like the coordinates, the radius, the battery status, and also some mission features like ID, pickup, and delivery date. We can all... Sorry for that. No.
Is it on again?
Yes, should be on again.
Sorry for that, I didn't touch anything.
So, as I mentioned, I'm not familiar when the presentation went off, but we can see the marker, the geofence, and some basic mission information. We can also select any other marker on the map, and a few minutes ago, one colleague of MA48 told us there is some error with a marker near the river. Let's find it. It's this one selected and marked with an exclamation mark. We can see the geofence is right in the river. Something must be wrong. So let's update the geofence so the container won't get lost. And there is another one with a missing exclamation mark right in the center. This one we have to pick up, so let's plan a route. We directly get the route from the base to the container. And as Laila mentioned, we also implemented the history feature, so we can select any marker in the list and see where the tracker has been around Vienna. To summarize it up, I think we have some container next to us right now. As this in the back is the Rathaus.
Thank you very much. This was very impressive, not only your solution, but also your eye for the time, because you were right on time, so thank you very much for that. I want to continue with the next team from the University of St. Pölten, which is Paul Hitzl, Lukas Pesendorfer, Jona, Josef, Zeichen. Please come on stage.
Hello and good afternoon. We have no presentation, so we'll jump directly into our prototype. We have very similar ideas to our colleagues from USTP. We also have a dashboard interface to use all the data the trackers gather to have a general overview for not only the dispatchers but also the drivers, which is also possible in a mobile view, so the drivers have their data on their phone with them when they drive around. Let's begin by looking at the admin view, which is a general account which allows to add drivers and containers, and also have the general overviews of the dispatcher. So first of all, we can see a general overview of how many containers we have, active containers, containers in motion, etc., and also active alerts. If we look into the active alerts, we can see the active alerts go from batteries to movement or no GPS signal. And at the bottom, we can also see there seems to be a container that's outside of Vienna city bounds. So let's check where's that. Ooh, this guy must have been stolen. So there is a geofence around Vienna, and all the notifications go into this alert system, which also acts as a theft system for containers which go outside of Vienna. If we now go onto the containers, we can see where containers is placed, what their battery status is at, and their local address or like location taken via geoencoding. If we now go onto a disponent account, which has less features than the administrator, as a theft regulation system, so only one admin can add containers or remove them in case some shady business is going on, and one driver just adds a container, takes it somewhere else, and then deletes it again as if never anything happened. In the dispatcher, we can go on and give drivers tasks. We can say, okay, Mr. Thomas Gruber, you need to pick up container 1 Müllbehälter 1010 A01 and deliver it tomorrow, oh no, today, with a priority of high, and we can add him notes, and we can assign the task to the driver. Which is, yeah, so this is like a disponent view where in the office they can plan tasks ahead or for the day and send them immediately to the drivers. And the drivers then, on the other hand, have their own accounts. This one is just a desktop view at the moment. If it would be on the phone, it would of course be responsive and smaller. The driver, on the other hand, sees what containers they have to pick up. They see the date when they have to pick it up. They see the status if they have to pick it up, to deliver it, or to exchange existing containers to empty them. And then they can place start navigation, which then puts them into Google Maps, which is on the phones much more handleable than a integrated map. And the navigation can start from the position of the driver in case they are outside on the move already or in the base to have the best route to the container. On the laptop there's Google Maps open, so okay, now it's on the presentation too. But yeah, in general, that's the general idea of it. We use the data to create a more acceptable and feasible interface to allow the communication between the dispatcher center and the drivers, and reduce also paperwork and have a better overview of what's to do, what has been done, and where the issues are. Thank you very much.
Thank you very much, gentlemen. We are switching it up from the University of Applied Sciences, St. Pölten, to the Technical University of Bratislava, STU. Team Sviatoslav, Sarov, and Danylo Yaryna, I hope I pronounced that right. Please come on stage. This is your applause, and here are your 4 minutes.
Good afternoon, everyone. And today we present Smart Asset Tracking. It's a project designed to convert our just raw IoT data into really practical tools that can help city and that we can use to check where the containers or anything else. So our solution is not just about seeing where the containers is. It's also about how we can use information where it is and how we can implement it. So the first first we need to understand that managing urban and dense Vienna city it's a really big problem. It's a massive logistical puzzle, and efficiency it's not just a goal, it's a necessity for us. It's a necessity for the Vienna city to keep moving and to city works properly. So let's look at the scale, or look at the scale of all of this. Here we can see it's 1,020 total containers active in Vienna city, including a high-tech 240 waste compaction containers. And it's not just about this. It's also about that containers. Its cost per unit can be even up to 22,000 euro per one asset. So, as we can see, 40 transports per container annually has some visual gaps. For example, it can be current maps and statics are reactive, it's logistic errors, and also can be thefts. And how we fix it? It's we use our data that give us. We use data for almost 641,000 LoRaWAN trackers, and our system is, how I said before, not just points on a map. It's not just a visualization of data. It analyzes battery health. It analyzes every point on map. It analyzes trip counts and movement velocity. It's a lot of aspects about containers, a lot of nuances. So as we can see here, it's our solution. We can see here our dashboards. It's you can see a map with all the visualization where containers, where they're moving. For example, we can see here it's 294 containers in total, and for example 88 moving containers. As we can see, with battery, everything okay. So we don't have alerts about battery. We can even see where these containers. We can see with which speed each container moves. So it's a lot of, how I said before, a lot of different aspects about containers, a lot of different things. And I give to my friends. He can continue.
Okay, I will shortly try to describe the architecture and the solution by itself, how prototype works. So, what we have here, we didn't have any kind of real servers that produce data, so we used 2 last months of data as a simulator. Then all of the data goes to the matrix endpoint and being ingested into PostgreSQL to calculate geofence and check is that all right zone to operate in this box with a container. And all the metrics going into scalable Victoria metrics database. Then using VMA alert, we can create custom alerts rule and see all kinds of alerts. Because the main challenge, what we was trying to solve is the scalability of that system working prototype and how we can use the data to optimize it in the future. So here's a few custom alerts we used, but the system allows us to write ProMySQL queries, so we can create even new queries later. This whole system is only a blueprint of it, and it can be outgrown into something even bigger. It was already tested with a simulator, and it can easily works with minimal resources, with 10,000 of IoT devices sending data 10 seconds each.
Thank you. Here it's our expectation how it all will work. So we expect that our project will have like asset recovery rates 98 or even more, And the main what we want to do is eliminating all human errors that can be caused without this technology. And one of important things that this project can be implemented not just here. It can be implemented in smart urban forestry or water infrastructure or other things. So it's really scalable. Thanks so much.
Thank you very much, Sviatoslav and Danylo.
I'm sorry.
And for our last presentation of the last challenge of tonight, I want to invite on stage Team Fatih Simsek, Mathias Holzinger, Emre Kaygisiz, Thomas Schuster from the University of Applied Sciences in St. Pölten. Stage is yours, and this is your applause.
Okay, hello everyone. We are the last pitch for today. I prepared a video which is exactly 4 minutes, so time shouldn't be a problem. Yeah, we just have to look that we start the video at the same time. 1, 2, 3. Okay, so we had the same challenge like the other colleagues. We made a web application to track assets, to track containers in Vienna. And is it already running? I think it is, yeah, okay. And we are not programmers, so we had to look for a possibility to develop it otherwise. So we took Cloud Code, which where you can create coding agents. So we got a developing team inside of an AI. That's how we created the web app. There's also some feedback loops, so it's always writing down what's wrong and Cloud Code working it into the web application. So there are also typical roles like an architect, a front-end engineer, and so on. So that's the application which we developed. On the left-hand side, you can see the map of Vienna, which is a heat map. You can zoom in there, and certain the detail you can see the containers. So that's what the data set provides. We visualize it with a map, and on the right-hand side, you can also see it in a list form. So everything is clickable. For example, if you click on a container, it will directly jump into the map where it's located. So it's demonstrated here. There's a switch for, I think, 3 locations. And there are also some details to those containers. You can select those containers on the map and also plan a route for the driver. So then it will forward to Google Maps. And the starting point is the MA48 home base. And it makes a route, an optimized route over all collected containers back to the home base. Yeah, you can also filter for overdue containers, for due soon containers, and containers which are currently okay. And you can also text with the container Charlie, which is AI. You can ask him, where are the nearest container to Stephansdom? And he will list the 3 nearest container. You can ask basically everything. So, and on the next animation, you can also see which sensors are currently not working. And we also developed a mobile application. So everything which we saw is also available on the smartphone. You can zoom in, see the containers, chat with Container Charlie, so everything which is available on the desktop is also available on the smartphone. yeah, you can also search for a district, for example, here Donaustadt. Then you will see all containers which are located in Donaustadt. You can, okay.
Sorry about that.
It was too fast. You can also try it on your own. We prepared a QR code. Maybe we can go back to a few seconds.
I'll try.
Yes, that's perfect.
Yeah, a little more.
A little more. So everyone can try it on their own. We got a QR code. You can chat with Container Charlie, ask them about the current Vienna container situation. And yeah, that's it from my side. Thank you, sir, very much for your attention. I hope you liked it.
Please stay on stage, and everybody from the City of Vienna Challenge, please join us on stage here to receive your awards, to get your picture taken, and afterwards we can go ahead and close our session today. So, everybody from the Vienna City's Challenge, please get up.
Get on up and
Come
up on stage, please, quickly.
Get your awards, get your picture.
And while we await this, I can let you know that we will possibly run over a little bit, or have already, but no worries, networking and buffet will be prepared on time and it will all be all right.
Please go ahead, also pick up your prizes, pick up your awards.
Only one per person, please. Only one. Say again? Please check out with Sandra in the back, okay? She's over there. I cannot decide that, you know?
Great, thank you so much, and a huge round of applause for our finalists.